taking our front row?
I am. I don't know a lot of games. I'm gonna get a 98 here.
I'm doing the same.
What'd you get on this semester?
I'll take a 97.
Is that after
You're
we
taking
do
a
it?
97. Okay, we are in our notes.
0.2% off.
We are ready for example 4 in 2.13. Okay, so find your 2.13 and we're ready for example 4. Look in part 1 right here. Part 1, 2.13 has 2 parts, and we're in part 1 of 2.13, and we're ready for example 4. Okay, no, that's not it. That's part 2. This is part 1. Okay, so I need everybody to double check, make sure you're in part 1 of 2.13, and we are looking at example 4. You'll know how to do this. There's nothing new and exciting here. But we do need to remember that logarithmic functions have domain issues, right? You can't take the logarithm of a negative. So when I look at this problem, example 4a, and it says solve this equation, the very first thing that I want to think about, and maybe I'll even write it down, is that whatever x ends up being, it has to be bigger than 0. And this one also has a stipulation, x would have to be bigger than what? -7. Now, since it has to be both of these, that one doesn't really matter, because it has to be both of these. So obviously it has to be bigger than 0. But you want to think about that, because when you solve this out, you could get an extraneous root. And it would be extraneous because it doesn't meet these qualifications. All right? So here we go. Let's solve it. What's your thought? First thought. You know how to do this. Huh?
Get rid of that 3.
Get rid of that 3. And how do we get rid of that 3? We remember he is an exponent. So we have log base 4 of x minus log base 4 of 8 equals log base 4 x plus 7. All right, now what? Combine them, and we combine them as a division problem. So this is going to be the log base 4 of x over 8 equal to the log base 4 of x plus 7. Everybody with me? And then what? We get rid of these now. So x over 8 equals x plus 7. So x equals 8x plus 56. So negative 7x equals 50. Did you get negative 8? Check my arithmetic. Is that okay? But what? Remember, you wrote this down right from the very beginning. In order to be doable, workable, mean anything, this problem, all your x's have to be positive. And that's not. So therefore, you just did all that work, and what's the answer to the question? No solution. No solution. All right, tell me about this one. It's almost the same exact thing. Tell me, what does this say? X has to be bigger than 0. And what every x has to be dealt with. What does this one say? X has to be bigger than 7 halves. So whatever you come up with as an answer, it has to be bigger than 7 halves. You have to be both of these. Okay? Alright, so go ahead, let's solve it, see what we have. Log of x plus, is this gonna be log 8 again? So log, this time I will multiply, right folks, remember that? We're multiplying now. So 8x equals 2x minus 7. Oh my gosh. Did we get no solution again? Yep. That Mr. Passwater is getting tricky with this. Alright, let's take a look at number 5, example 5. So that's one function. Here's another one. And what does it mean if we want to find where they intersect? Where they equal each other. So we're just solving the equation. This guy right here. And I don't care if you check at the beginning or the end, but at some point you have to make sure that whatever your x is, it's bigger than negative 10, it's bigger than 0, and it's bigger than negative 3. So ultimately, we put all these together, we have to be all of them. What do we have to be? It looks like we gotta be bigger than 0. All right, so here we go. You can do this. It's gonna be a division problem. Everybody okay with that? And we can draw our logarithms. Oh, this is gonna be wild. Are we gonna get a little quadratic out of this? Oh, I love my front row. So, what do we got? X squared plus 2x minus 10. What now? Speak up, I had a birthday, now I'm 66 and I really can't hear.
Quadratic equation.
Now I'm going to use quadratic formula, yeah. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What is that? Is that 44? Which is 2 root 11. Did you get negative 1 plus or minus the square root of 11? Now, what did we determine right at the very beginning of the problem? That whatever happened, x had to be bigger than 0. Now this is two answers, -1 plus root 11 and -1 minus root 11. Is that bigger than 0? Yep, because root 11 is obviously bigger than 1. Is this bigger than 0? No. So our only answer to the problem is that one right there. Obviously, if this is a calculator question, you can type those in and get decimals if you want, but it wouldn't have to be a calculator problem. Okay, would you and your partner work on example 6? Don't let the directions scare you. Aren't you just setting them equal to each other? Where we left off. So if you just find where you left off, we are now on example 6.
Yeah. Bigger than -4. It has to be bigger than -2. Well, because in this case, but there's no qualification that says it has to be bigger. It has to be bigger.
Where do you see the qualification has to be bigger than 0 on this level?
I wanted to do it.
Because it was a
Like, are you just setting each?
Yes.
You're setting on
Yes.
equal to 0.
Yes. They all have to be bigger than that. Okay, folks. How'd you do? I came out with 7/2. I don't know. Is that what you got?
Yep.
Did you recognize you had to be bigger than 3/2? -4 and -4. And luckily, 7/2 is bigger than 3/2, so we could go with this one. We had to rule out that one. all good? All right, hang on to that, because in a minute we're gonna do the same thing with inequalities. But first, we're gonna do a few, basic exponents. We did a bunch of these, I think, before. So let's just review this real quick. This is number, example 7. By the way, we don't have to worry about extraneous roots with exponents, because can exponents be negative? Yeah, that's not a problem. So I'm not worried about anything with my exponential problems. It is my logarithm problems that have issues. By the way, that goes back to your BFFs. What's the domain of the exponential? Negative infinity to infinity. There aren't any issues. But what's your domain of your logarithmic function? Bigger than 0, right? So because the logarithm has built-in domain issues, every time you do a logarithm problem, you gotta think about that. All right? Exponentials do not have built-in domain problems, so I don't need to fret about it. Okay, what's the really good news about this problem right here? They're both powers of 2. So 5x minus 1 equals 2x plus 7. If I didn't make any mistakes, I got 8/3. So easy. B is a tad more complicated because why? The bases are not the same, so you can't just set the exponents equal. However, can you make the bases the same? Yep, by rethinking 8 as 2 cubed. What do I do here? Multiply. So 9x minus 6 equals x plus 5. I got 11/8. All good? C is even a little bit more work because 27 is not a power of 9, or not a whole number power anyway. So maybe it would be best to do what with problem C? Change them both into 3s. So we have 3 squared and 3 cubed. Does that make sense to everybody? You could mess around with fractional exponents, whatever, but I think it's easier just to change the 9 and the 27 into powers of 3. So 4x equals 3x plus 6. Did you get 6? Now you and your partner are going to do D. So discuss together, figure out what base you're going to use. You'd like to get a common base. If you can't, you'll need logarithms, so you really don't want to do that. We're going to get a common base. Think about what base you're going to use.
Or what you do for grade?
Freshman. It was fine.
They do it different every year, huh?
Yeah, I think they do a lot of the same stuff they've done in the past, but, yeah. negative 1? Does that look okay? I changed, I added them into 2's. You could change them into something else. So I made 1/2 2 to the negative first. And then 4 was 2 squared. Is that all right? You got what? Did I mess it up?
No, I think
You think you did, or you know you did? Come on, I could have made a mistake. Let's figure it out.
Well,
What?
I got negative 14 over 11, but I changed them in.
So what did you? Am I doing the same problem as you? So what did you change your bases into?
4.
Okay, so this became what?
4 to the negative 2.
No, 4, there's your mistake. 4 to the negative second is 1/16.
Okay.
If you want 1/2, it would have to be 4 to the what? What's 4 to the negative 1/2? What does that mean? 1 over 4 to the 1/2?
Yeah.
And what does 4 to the 1/2 mean?
1 over 6.
Square root of 4, yeah. So, again, as long as you do it correctly, you can use 4 as your base. But let's try to make our lives as simple as possible, right? But yeah, that's your mistake. 4 to the negative second is 1/16. All right, we okay? All right. Let's go on to part 2 for 2.13. Here is our problem. Our equation, there it is. There's your equation. And your job is to find the inverse. You know how to find inverses. What do? We have an equation sitting in front of us. We switch x and y. So this is going to become x equals 3, 2 to the y plus 4 minus 15. Now our job is to get y by itself now. Ultimately, we want to do whatever we do and end up with y equals, and that will be our inverse. So how about if we add 15? What are you feeling now? Divide by 3. So this is going to be 1/3 x plus 5 equals 2 to the y plus 4. Everybody okay with that? I'm trying to keep things as neat as I can. You could, but I'm thinking about what's going to come next. I kind of like that, but it's the same thing. Same thing. Now wait a second. Wait a second now. I need to get y by itself. It's an exponent. There's only one way to do that. How do I get it down? Logarithm. I'm going to have to log both sides. And remember, when you take the log of both sides, you can use whatever base you want. So I would suggest, since the base of the exponent is 2, let's take the log base 2 of both sides. Now, what's so nice about that? What would be the only nice thing about that is what? What happens when you take the log base 2 of 2? So all we have left is y plus 4. Remember, we're solving for y. So let's subtract 4. And that is our inverse. So let's go through that one more time and make sure everybody's okay with what just happened. We switched our variables. And then we started just trying to get this by itself. So we added the 15 divided by the 3. And then this is the magic step then. Once we got this 2 to the power by itself, we logged both sides. And we chose base 2 so that would go away totally and give me the neatest, cleanest possible answer. Anybody have a question about that? Bennett, you okay?
Yeah.
All right, find the inverse of this one. Now, the original problem we just finished, it was an exponential, and its inverse came out to be a logarithm. So now, example 2 is a logarithm. What do you think its inverse is going to come out to be? An exponential. All right. Mr. Pack, what's the first thing you think we're going to want to do here?
Place y with that.
Absolutely. You're finding an inverse, and that's exactly what you want to do. Very good. Very good. Would you agree that maybe now we ought to try to get this part of the problem by itself? So maybe we'll subtract 6. And divide by -3, and you can either do that in one chunk, or I'm gonna split it up. But you can do it in one chunk, it doesn't matter. Truly, makes no difference at all. So you can move like this if you want. Okay, now, okay, here's where we are. I'm trying to get y by itself. What do you think I might do? Alex?
Do the logarithm.
Loop-de-loop? Yep, we're gonna loop-de-loop this thing. So we're gonna say 5 to that power, 5 to the -1/3 x plus 2 power equals y minus 4. And then add 4. Make sure you're adding 4, not up here. Oh, that's the exponent. Add the 4 down here. And that is your inverse. man, it feels good to be back at school, doesn't it? Example 3. Take a second with your partner, take a couple minutes with your partner, and develop a game plan. What are you gonna do for example 3? Don't just sit there. I need everybody thinking.
X plus 2. I have X plus 2 equals.
And assuming we have such.
Just start with that.
No, I thought you were.
Okay, so the seating chart is coming around. I need everybody to sign it in the appropriate spot. Make sure you're signing it behind whoever's already signed it.
Hey, Suresh.
Yes.
Take the pass.
Oh, we have a pass.
All right. Did anybody come up with an answer yet?
I got X equals 7.
X equals 7 is an answer that somebody came up with. Let me see. That's what I got too. Tell me how you did that.
So I found the inverse of h of x.
Okay, so let's stop right there. So you find the inverse of this?
Yes.
So x equals 3 to the y plus 1 minus 2. So x plus 2 equals 3 to the y plus 1.
And then I logged both sides.
So log, did you use base 3?
I did.
X plus 2 equals y plus 1, because when you base 3, that cancel. So log base 3 x plus 2 minus 1 equals your inverse k of x.
Yep, and then you're looking for k of x equals 1, so I set that all up with a 1.
So log base 3 x plus 2 minus 1 equals 1.
Yep. And I added the 1 over.
Log base 3 x plus 2 equals 2.
And then I loop-de-loop.
3 to the second equals x plus 2. Beautiful. Beautiful. Now, let's talk about what he did. It may or may not be what you did, because there's another way to do the problem. But let's talk about this. He found the inverse of the original problem. He found K, in other words. Does anyone have a question about any of his work? This is what he got for the inverse. Anybody have an issue? And then he set it equal to 1, because that's what the problem said, and just solve from there. What do you think, folks? Are you okay with that? Did anyone have a different strategy? Alex?
So I knew that, it was setting y equal to 1 by the inverse. So if it's setting y equal to 1 on the inverse, then you set x equal to 1 on the original problem.
Bingo. K is the inverse. So we're setting y equal to 1. Which means for the original, x had to be 1. So what happens if you put 1, this is the original, what happens if you put 1 in there? What do you get? 3 squared minus 2, which is 7. Okay, remember that relationship, inverse is flip-flop. So if one of them has a y value of 1, the inverse is going to have an x value of 1. Okay? Perfect. All right, flip it over and there's some inequalities now. Alright, so basically we want the log minus the log to be bigger than 0. Would everyone agree with that? Okay. Now we're going to solve this just like we've solved other things, but just like we've done before, we need to stop and think about all this stuff has to end up being positive. This, whatever it is, has to be positive, that has to be positive, and then on top of all that, the whole shebang has to be positive. Alright, this is kind of a hard one. Alright, let's go ahead and start solving. My base 10, yeah. Alright, so here we go. What am I going to do with these guys? If that becomes a division problem, so this is going to be x squared minus 4x plus 7 over x plus 3. Thank you so much. Everybody okay so far? Now what do you want to do?
Factor the top.
I would love to factor the top. I don't think it factors. Does it?
No, I don't.
Well, what would you do if that were an equals? You could loop-de-loo it, right? So what's my base here? So 10 to the 0 is x squared minus 4x plus 7 over x plus 3. Would you agree with that? What's 10 to the 0? 1. All right, what would you do with that?
So you can multiply the x plus 3.
Multiply the x plus 3 over. now we have a little quadratic to solve. With any luck, maybe this one will factor, let's see. Is that okay with everyone? Okay. Are we okay to this point? We are not done. But are we good here to here? Does this make sense to everyone? All right, I'm going to draw my handy dandy number line. And on that number line, I'm definitely gonna mark a 1 and a 4. Because wouldn't you agree that those two numbers are important in this problem? There are other important numbers in this problem. For example, -3 is an important number in this problem. Why is -3 an important number? Because x has to be bigger than it? Would you agree with me? What about this? This is what makes this problem hard. Doesn't that also have to be positive? How in the world am I going to figure that out? Well, okay, and then do what with it? Quadratic formula. Wait a second. What about that?
Negative number.
So those roots should be imaginary, right? I'm not gonna have anything to put on my number line. These values right here are never going to be 0. You can't solve them and get 0. So therefore, they're either all gonna be positive or they're all going to be negative. So pick a number and plug it in. I put in 1. That turns out to be positive. So this thing is always positive. So it is not going to be a factor in my determination of the solutions because it's always going to be positive. There are no bad numbers for that one.
How did we determine that it was like always positive?
Well, this tells me that it's never 0 on the real numbers, right? It's a parabola. And it either opens like this or like this. It's either always positive or always negative. So I just picked a number,
Oh, got it.
right? Now I can also tell that because it's opening up, it can't, and it doesn't cross the x-axis and it opens up, they always have to be positive. That's another way you can tell. Okay. So now I think I've covered all my bases in terms of important stuff. I know that x has to be bigger than -3 in order for the problem to work. So now I just need to figure out, I erased this step in here that was kind of important. No, maybe not. Maybe I can do it. Now I need to figure out where I'm going to shade on that number line. Huh?
Plug the numbers between.
Yeah. So now I'm going to do a sign chart, just like I always do. So maybe I'll pick a number in here. A good one might be 0. So this says the log of 7 minus the log of 3 is positive. Now, you don't know off the top of your head the log of 7, and you don't know the log of 3 probably off the top of your head, but which one's bigger? 7? So wouldn't that be true? Would everyone agree with that?
Yeah.
So these numbers in here seem to work okay. All right, what about 2? So that would be the log of, what if I put in 2? 3. If I put in 2, I get 5. What about that? That does not seem to be good. All right, how about 5? What do you think about that one? What was that? I heard somebody say negative. I think that one is
That's a
going to be
boolean problem.
positive, isn't it? One quick comment before we finish this up. We kind of got lucky. This was messy, and at first it scared me to death because it didn't factor, and I thought I was going to have to deal with radicals. But could I have gotten 2 more important points out of this part of the problem? Yes. And therefore there would have been 2 more dots on the number line and more sections to look at. Right? Okay, so we got kind of more. Okay. Let's put 1 in. I'm a little curious as to whether that dot should be colored in or not. I don't think it should be. Let's put 1 in and see what happens. If we put in 1, what do we get? Log 4 minus log 4. Is that bigger than 0? No. If this had been an or equal to, would I have colored in that dot? And probably this one too, because it came out of the same part of the problem, but never this one, because where did that dot come from? And that can never be 0, so x is bigger than -3, period. Okay, so what's my ultimate answer then? After all this messing around, my answer is -3 to 1 and 4 to infinity. What do you think about that? That is a whopper of a problem. And good news, we got a couple more. But we're gonna have to save it because we're almost out of time. So we are almost finished with 2.13, not